Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Stellar Cores Affecting Earth and Possible Connection to Volcanic Eruptions. The Earth has experienced several unusual tidal events in the past several months. The ocean has receded to levels never seen before in various coastal regions around the world. Several of these events we can see here, and this was at the coast of Uruguay, Ponta del Este, and we can see that boats were left sitting on the mud in the harbor as a result of the ocean receding, showing that there was an extreme low tide. The water did come back eventually. This occurred on August 11, 2017, and then around that time, August 12, 2017, the Brazilian coast also experienced an extreme low tide event, which we can see here, unprecedented, and the ocean receded and the beach was left empty. You could see the sand that's usually always covered by water. Now, there were no storms or hurricanes anywhere near these coastlines, and these were unprecedented events showing very low tides occurring. And something like this also occurred in Tampa Bay, Florida on September 10, 2017. The beach was left empty due to the ocean receding. There was a hurricane affecting the area, but the hurricane passed overhead before the water started returning the next morning, showing that the ocean recession did not occur as a result of hurricane winds. If this was caused by the hurricane, then which is extremely unlikely, but that's the excuse that's usually given. But we've had hurricanes affecting coastlines for thousands of years, and we know and these things have not actually been noticed before. If anything, sometimes the water comes on shore. It doesn't leave the coast instead. So, but anyway, this could not have been caused by the hurricane because the hurricane passed overhead without the water returning. It only returned the next morning, many hours after the hurricane had passed. And we have this one. This one is in an island, Sakhalin Island, and here we have the ocean receded, also unprecedented. And but surprisingly, and this is detailed in Article 188, what is causing the ocean to recede all over the world. And these are not just all the events that have occurred. There have been many more. I just looking at a few of them. But this one is interesting because this occurred on March 20th. And then on March 21st, a volcano just north of this island erupted. And this was the Epico volcano in the Kuril Islands. And this is the volcano erupting on the day after March 21st. And you can see that the two regions are very close to each other. The Sakhalin Island is over here, so this event of low tidal, very low tidal event, or ocean recession occurred here, and this is where the volcano is. So this suggests a connection between the two events. Now, the mechanism behind tides is well understood in terms of accepted theory. It is well known that ocean tides are caused by tidal forces exerted by the moon. Tidal forces are differential gravitational forces. They are due to the gravitational attraction of an object close to the Earth, which is normally the moon, exerting a much stronger attraction over a certain point on the Earth's surface than another. So this is illustrated here. So the moon, because it's so close to the Earth, exerts a much stronger gravitational attraction on the Earth, all points on the Earth that are in line with it. So the ocean right below the moon feels a much stronger attraction towards the moon than ocean further away. And this causes, therefore, what I call a differential in gravitational attraction. And this is what causes this tidal bulge towards the moon, or right below the moon's position with respect to the Earth. And it causes a similar tidal bulge on the other side of the Earth, because the Earth's gravitational pull on this portion of the ocean is reduced by the effect of the moon in line with it. So this is why we have a tidal bulge on both sides. Now, the sun does have an effect, but not as strong as the moon's. So if the sun and the moon are in line, we have a tide that is 30% higher due to these two being in line. So either the moon is at the new moon position, where we do not see it because it's in front of the sun, and as we know, the moon reflects sunlight, so in this position we would not see it, would look dark, or at the full moon position, where it's the whole surface visible from this point on the Earth would be visible because it's all reflecting light from the sun, it's facing the sun. So at these two positions we get higher tides and also lower low tides. And if the moon is at third and first quarter position, we also get tides, but not as high. But the effect of the sun is much smaller. And it's much smaller than the moon's because the sun is much further away. So we don't get this differential in its effect. It affects the oceans over here and over there in a less different manner, let's say. It has almost the same effect on the ocean over here as over there because the sun is much further away. And the sun's gravitational attraction on the Earth is actually much, much greater than the moon's. I actually calculated here. So this is the equation according to Newton's law of universal gravitation for the force exerted by the sun, which has the gravitational constant G, which gives us the strength of the interaction, times the mass of the sun, times the mass of the Earth, divided by the distance between the sun and the Earth squared. And the mass of the sun is given by this number, 1.99 times 10 to the 30 kilograms, and the distance is 150 million kilometers. Then the gravitational force exerted by the moon similarly is G times the mass of the moon times the mass of the Earth divided by the distance between the moon and the Earth squared. The mass of the moon is 7.35 times 10 to the 2 kilograms, and the distance 384,000 kilometers. Written in scientific notation there. And then the ratio of the two, so the force exerted by the sun divided by the force exerted by the moon, is given by equation 1 divided by equation 2, which ends up as this expression here, mass of the sun over mass of the moon times the distance between the moon and the Earth squared divided by the distance between the sun and the Earth squared. When we calculate that, we get 180, which shows us that the sun's gravitational attraction on the Earth is 180 times stronger than the moon's, even though the moon is much closer than the sun. However, the sun's effect on ocean tides is only half that of the moon. And this is because the tidal effects are due to tidal forces, and even a smaller object, as in the case, will have a much larger effect if it is much closer to the Earth. So the stronger the tides, the closer, basically, the object has to be to the Earth. So we could either have an object that is close, like at the same distance as the moon, but it would have to exert an extremely stronger pull. But it is actually more likely that it's an object that is not exerting the same gravitational attraction as the moon, possibly less, but it's much closer to the Earth in order to cause this extreme differential or tidal force. And we see illustrated here the effect of the sun on the oceans. It causes a small tidal bulge. And the moon's, even though the moon's gravitational force is much weaker because it's much closer, the bulge is much larger. And this is the two together. You can see there's quite a difference. Now, but in order for the Earth to experience the unprecedented low tides it has experienced in places like Brazil, Uruguay, and Russia, and it has in other places as well, there would have to be an object exerting a stronger tidal effect on the Earth than the moon. This could either be an object about the same distance as the moon, but exerting a much stronger gravitational attraction on the Earth. But as I said before, that's less likely than an object that may exert a smaller gravitational attraction than the moon, but that came much closer to the Earth than the moon does. Now, no known object in the solar system comes closer to the Earth than the moon, which suggests that an object which is not a known object in the solar system was responsible. Now, we know that a system of stellar cores has invaded the solar system. These objects are usually found in the sun's corona. One of these objects, well, some of these objects are shown here, and this is the one that I like to show because this is undeniable. We have an object with stripes. The stripes follow a curve. They are curved, and they follow the curvature of the object, indicating that we have a spherical object that is striped within the sun's corona, and this is an SDO composite image showing this object in the sun's corona. We have here a cactus image, and this is from September 26, 2017. The first one is from December 25, 2017, SDO composite image. And as you can see, a spherical object in this cactus image. This has to be an object that's very close to the sun. It's within material that the sun is ejecting. These particular images are meant to show CMEs, so this object has to be very close to the sun, at least within the sun's outer corona, if not the inner corona. This one is in the inner corona. This one is in the inner corona as well. This is a 193 angstrom SDO image. And we see the object there making the connection. This is just a close-up of that region of the sun. We can clearly see that there's a spherical object within the sun's corona there making a connection with the sun, like these objects have been caught doing many, many times. Some of them are huge. As you can see, there's obviously a spherical object there within the CME material ejected by the sun. Some are small, and most likely the ones that are coming close to the Earth are the smaller ones. And we could have large ones as well. They do not exert a strong gravitational attraction on any of the known celestial bodies in the solar system until they come close to them, very close. So as you can see, this one is striped as well. This is a LASCO C2 image, obviously an object inside the sun's corona there. This is from October 13th, 2017. And a lot of these have been caught by Scott. He's very good at catching these objects in these SDO. This is a stereo A-Cord 2 image. And they've been caught in all of these spacecraft images that are meant to observe the sun. Now, several of the stellar cores which have invaded the solar system are shown here. These objects do not interact gravitationally as the known objects in the solar system, as the gravitational forces they are able to exert are much lower than those the known objects in the solar system exert. And this can be clearly seen from the fact that the 2007 stellar core traversed the sun at a speed which was much lower than the sun's escape velocity. If the object had interacted as expected, it would never have been able to leave the sun. It would have impacted the sun and would still be there. And we see the stellar core here getting ready to traverse the sun. You can see that this object does not emit light in this wavelength, which is extreme ultraviolet, 304 angstrom wavelength, because it's dark on the outside here. But the part of it that's within the sun's corona looks red, because the sun's corona is emitting this wavelength of light, which is in these images looks red. So we can see part of it entering the sun's corona. That's why that part is red. That means there has to be corona between the object and the detector. And in all of these images, it is within the sun's corona, and that's why it looks red. If it was outside of the sun's corona, this object would look black against the background of the sun. So clearly the object is within the sun's corona, and therefore extremely close to the sun. And it traverses, and we can calculate its speed because we know it takes 10 hours to traverse the sun, and we know the sun's diameter. So its speed is 39 kilometers per second, or 24 miles per second. This may seem high at first, but the sun's escape velocity is 616 kilometers per second. At the top of the corona, which we could say goes up to 0.5 the radius of the sun's escape velocity would be over 500 kilometers per second. This is still way above this 39 kilometers per second. So clearly this object was not moving fast enough to escape the sun's gravitational attraction. So it should have stayed there, but it did not. And this indicates that the strength of the gravitational attraction that it is able to have with the sun is much weaker than a normal object that is able to interact like all known objects in the solar system. And I've written extensively about the fact that G, the strength of the gravitational interaction, is not actually constant. This is what these objects indicate, that it varies according to the gravitational energy the object has. And these are dead stars. Their gravitational energy is low. This is also why they are attracted to host bodies that have higher gravitational energy and that still generate a strong amount of gravitational energy. I'll also discuss that it's due mainly to fission occurring in the core of these objects, stars or planets. I've also detailed in many of my articles how stars and planets are not that different from each other. So these objects are dead stars. They're low on gravitational energy. They come to the sun and other host bodies, it seems now, like planets. They draw gravitational energy. They get stronger, and eventually they are able to emit light once again. So the gravitational interaction strength for the stellar core was only 0.6% of what is normal for the known objects in the solar system. And you may look at Article 153 entitled Escape Velocity and Gravity for more details on that. Since they gravitationally interact so weakly, their gravitational influence is not felt until they are very close to a solar system object, at which time the interaction can only be tidal in nature. In fact, the matter connection they make with the sun, through which they draw matter from the sun, has to be tidal in nature. And this is what we see here, one of these stellar cores. This is again one of the smaller ones, only about half the size of Jupiter. That still makes it 5 times larger than the Earth. And it's drawing matter from the sun. As you can see, we see this vortex of matter connecting it with the sun, and it's drawing this matter through tidal forces, a differential gravitational force. It's able to exert a strong enough gravitational force at this point on the surface of the sun, but its gravitational attraction out here is much, much weaker. So it's then able to draw matter through this tidal force towards itself, making a connection with the sun. And these objects remain stationary with respect to the sun whilst they make these connections. So this is illustrated here. Our stellar core in the sun's corona is able, through tidal gravitational forces, exert a strong enough force to pull matter from the sun's chromosphere and create these plasma connections, these matter connections with the sun. And you may look at Article 210, stellar core gravity, tidal, and G is not constant for more details. So when they approach the Earth, they would do the same thing. They would make a matter connection, be it with the Earth's atmosphere, drawing atmosphere. Possibly when they first arrive, they are very weak. They possibly only draw matter from the Earth's atmosphere. They may have been here for quite a while. We may have lost quite a lot of atmosphere already due to the presence of these objects. As they get stronger, they will be able to draw ocean water. Eventually, they will be able to draw matter from the surface of the Earth and from under the Earth, if they are able to reach it. And in this way they gain gravitational energy. They basically will do the same thing to the Earth as they are doing to the sun. It's most likely smaller ones. I'm not saying it's not possible to have large ones, but I think the larger ones will tend to go to the sun, which is a much larger object than the Earth. But we may get some of them coming our way. We know that if they are coming into the solar system, they are likely to go everywhere within the solar system, not just the sun. And so the stellar cores in the sun's corona make connections with certain points on the sun's surface and remain over those positions for long periods of time. This means that they rotate with the sun. If these objects do the same with the Earth, they would be seen over the same point with respect to the Earth's surface for long periods of time as well. And in fact, there is evidence that this is occurring. And this is one of the objects, and this was caught by JFP in early March of 2018, obviously emitting red light, and seems to be surrounded by diffuse cloud that is emitting red light as well. So this object is most likely drawing matter from the Earth, ionizing it, and causing light emission, visible light emission, because we see red light coming off it. So this object remains stationary. JFP has observed it many times. Sometimes it looks black, sometimes it looks red. So obviously drawing and ionizing the material in different ways. So it emits different amounts of light at different times and different wavelengths. So this, at least we have at least one. We have this observational evidence, at least one. This object stays over the same position. It can be seen not moving across the sky as other objects move across the sky, but stays in the same position. Now, what objects seen in Earth's skies remain stationary with respect to the Earth's surface? Only geosynchronous satellites, which rotate with the Earth, would be able to do that. However, stellar cores, by making matter connections with either the sun or the Earth, make themselves part of the host body and thus rotate with the host body. And here I illustrate why we see everything in our skies seemingly move across the sky. So if we have an observer here on the surface of the Earth and the observer is looking straight up, in this position, this observer will see the moon and the sun overhead. It's about the midday position. But as the Earth rotates, the observer would move to another position. At this position, this observer sees the moon and the sun both have moved lower towards the horizon, in other words, towards the sunset position. And then as the Earth continues to rotate. The observer will come to this position. This would be the sunset position. The sun will seem to be setting for this observer. And as the Earth rotates some more, the observer ends up then eventually over here. And over here, the sun is not visible at all. The sun has set a long time ago for this observer, and the observer sees the stars. And as the Earth continues to rotate in this direction, so the Earth rotates in that direction, the stars will and the planets that are out there in the sky will seem to rotate or move in the opposite direction. And this is why everything in the sky seems to rotate as we look up at the sky. And it's only geosynchronous satellites that are at the correct orbital altitude to rotate with the Earth. That is, they have the same rotational period as the Earth, which is one rotation every 24 hours, and therefore seem to remain stationary over the same position and would therefore remain with the observer. But this is the only way that an object should stay stationary in the sky. But we see the stellar cores stay stationary in the sky and over a certain position with respect to the sun, because they become a part of the host body and so rotate with that host body just like geosynchronous satellites do. Or with anything that if an asteroid falls towards the Earth and it impacts the Earth, then it will remain with the Earth once it hits the surface. Now, even though the stellar core's gravitational attraction is weak, they will over time gain gravitational energy, and the strength of their attraction will increase, and thus their effects on the sun and the Earth will increase. Since these objects exert tidal forces in addition to causing greatly enhanced tides, the tidal forces will be able to cause earthquakes and the surface to shift and break, thus causing sinkholes to appear, and the Earth to break at a greatly accelerated rate along weakened regions of fault zones. And this seems to be what is occurring in Africa at the moment. And you may look at Article 201 entitled Africa Breaking Up, a preview of what is to come for more details. So here we see a large fissure that just appeared overnight in a region of Africa called the Rift Valley. It's a region where the Earth is moving apart, and this sort of thing is supposed to happen over a period of millions of years. But it occurred overnight in Kenya in March of 2018, indicating that these objects are affecting the Earth and causing these things to occur. So in addition, since volcanic eruptions are associated to earthquakes, and since the tidal forces are likely to have a pulling effect on magma under the surface of the Earth, it is likely that stellar cores approaching and making their matter connections with the Earth will cause volcanic eruptions. And this is what seems to have happened in the case of the Ebuko volcano in the Kuril Islands, Russia, on March 21st, 2018. And a large and unprecedented current eruption in Hawaii is therefore likely to be associated to the influence of these stellar cores on our planet. And here's an aerial photograph from May 7, 2018 of the Kilauea volcanic eruption in Hawaii. And it is likely that many more unprecedented volcanic eruptions will occur in the near future due to the influence of stellar cores closely approaching the Earth. And I noticed there was a 6.9 magnitude earthquake that occurred after this eruption started taking place, and that to me showed there was a major movement underground, because when volcanic eruptions start to occur, you usually have a release of pressure. So the fact that this strong earthquake occurred after that release of pressure had already occurred suggested to me there was a strong movement that was occurring inside the Earth, and this is possibly why the lava seems to be moving in a direction and possibly moving underground, and may therefore erupt in different places around the volcano area. Now, the tidal forces exerted by stellar cores closely approaching the Earth are likely to affect magma inside the Earth and may, if strong enough, cause crustal displacements. The fact that the Earth's magnetic north pole has shifted in one direction is likely to be due to such forces exerted by one or more stellar cores in orbit around the Earth, or due to stellar cores being repeatedly attracted to the same region on the Earth and thus making its connection at this particular point. And for more details, see Article 167, Magnetic Pole Shift and Crustal Displacement. In conclusion, unprecedented tidal events can only be explained by celestial bodies which exert a weak gravitational attraction coming very close to Earth and thus producing tidal forces. Since there is overwhelming evidence that a system of dead stars or stellar cores has invaded the solar system, it is very likely that these are the objects responsible for such events. The evidence therefore indicates that stellar cores are closely approaching the Earth and causing these events, and are likely to also have caused sinkholes, earthquakes, and volcanic eruptions. These effects are likely to increase in severity as these objects gain gravitational energy through absorbing matter from the Earth. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.